Hey everyone, this is Jesse Menning. I'm excited to be here to talk to you about Async API and its role that we see in driving the SDLC lifecycle, the software development lifecycle.
So it's interesting cruising around on the internet looking for things related to this talk, and we see a lot of things about life cycles. And one of my favorite things I found actually was from Ken Lane. Ken Lane works for Postman and does a lot of thinking about API lifecycle more generally, and sort of evangelizes the use of APIs. And I found this really cool diagram here that includes the Postman Spaceman. That's why there's a couple astronauts interacting there. And you can see that there's two interacting life cycles. This is for an API. You can usually visualize things that starting on the left. You need a producer in order to have a consumer. And then he sort of steps you through the different stages of a API, and then once the API is distributed, over on the right side, there's a consumer lifecycle. And of course, Ken does a great job of explaining things and walking through how things are given birth to, and also go through a life cycle, and then eventually, presumably, die after they're no longer needed. And it's interesting. We're seeing talking with people who are interested in event-based APIs, that there's this big desire to bring these kind of life cycles into event-driven worlds as well, using primarily actually AsyncAPI, and even more so is combining those two worlds of sync APIs and async APIs. I can't tell you the number of people I've talked with that want a single, one-stop shopping for APIs, whether they're synchronous, asynchronous, whatever they are. They want to have one place where a developer can go in and pick something that makes sense for their particular use case, and get access to that information very easily. So it's an exciting time, as we all know, for event-driven architecture more generally, and event-driven APIs as well. But thinking through it, it's interesting that there seems to be an interrelated life cycle here as well, and I'll focus here on the producer life cycle. There's certainly a correlate over to the consumer as well, but we'll just, for scope, focus on the producer lifecycle. And that is, as long as we are advertising these APIs, these event APIs, we need to actually have the ability to process them. In other words, if we can think of the API in a classical sense, it's the interface, but we still need an implementation to make these things real. And those implementations actually have their own separate and distinct lifecycle as well, which is as important as our API lifecycle. If we don't have the meat in the sandwich is just kind of bread and sits there a little bit. So, and obviously, these event-driven applications, if you're any size enterprise, you're going to want to have multiple environments and test these things and integration test them. And have a sandbox environment where your developers can go wild and explore ideas. And so you're going to need to have this lifecycle exist in multiple different places and have it be repeatable as you so desire. So I was thinking more about that and sort of the implications and challenges of that, and that's sort of the basis of this talk. How do we interrelate AsyncAPI, the producer API cycle, and then also sort of the event-driven application implementation cycle as well. So just giving you a high-level overview. What are the goals here? Well, talk briefly about async SDLC without AsyncAPI. Certainly a lot of people try to do that. Talk a little bit about the challenges in that regard. Talk about why AsyncAPI helps solve the challenges associated with SDLCs. And finally, room for growth, of course. Challenges that I see in terms of the AsyncAPI spec and using it for SDLC. So, plunging right in. Let's talk just a little bit briefly about what an async SDLC looks like without AsyncAPI. Because for a long time, we've had async architectures and we haven't had AsyncAPI. So what does that look like? I think the underlying challenge is that there is typically some infrastructure that's associated with async architectures. Certainly brokered architectures, which is kind of the world I live in. As you're moving things through environments, we have to make sure that things are in lockstep. Things like queues and topics and endpoints and security, and just there's a lot of configuration that's typically involved with moving an async application through environments. And that's a great thing. I mean, all the infrastructure serves a purpose, and I think a really great purpose. And since you're listening to the AsyncAPI conference, I assume I don't have to tell you all about that, but the decoupling is fantastic. But it's also creating this sort of shared touch point between a whole bunch of different applications that don't necessarily know about each other. That's decoupling. So it becomes a bit more of a challenge in terms of moving things through an SDLC. How do people solve it? Well, there's the classic, we're going to roll our own approach, and certainly I've worked for a lot of people who have tried that. There's a custom proprietary Java or Java JSON format that people use to describe things, or the properties of the application as it moves through environments. And there's custom scripting that processes those. A lot of times that revolves around the sort of raw object definition language of the particular broker that you're dealing with. And that's a viable option, but I would argue that that's actually kind of a constraining option as well. So let's move on. How could AsyncAPI help standardize SDLC? I aggressively have stolen slides from Fran because I think he has a lot prettier slides than I typically produce, and I think also that it shows that a lot of the concepts that are central to AsyncAPI that Fran eloquently talks about on a daily basis can be applicable not only to the interfaces of applications, but used for the implementations as well. So here you go. Here's Fran's slide on the purpose of AsyncAPI. And you can say event-driven microservices, Internet of Things APIs, streaming APIs, and pretty much anything based on messages. And I'll sort of glow those things out there. Those microservices and pretty much any system based on messages, once we move beyond the pure API use of AsyncAPI, we very quickly move into a realm where we're introducing implementation. And here's another slide that I stole from Fran. It says, the specification is protocol agnostic, which I think is fantastic. Avoids vendor lock-in, makes it, sort of generalizes things. Big points there. And as Fran says, Fran Mendez, protocol information is important for implementation details, but it shouldn't be a blocker for defining the interface. Absolutely. Don't worry about it until later. But the correlate is, eventually you're going to have a protocol or nothing is going to work. You're going to be shouting into the void. And that's from Jesse Menning. So how do we bridge that gap in AsyncAPI? Well, thankfully we have a fantastic solution for it. We are protocol agnostic, but we also have binders that allow us to define things in an open standard, best practice kind of way. And I think it's amazing because of the open source nature of things. You get the best of knowledge from an IBM expert, IBM MQ expert about this is what matters when you're defining an IBM MQ. And a Kafka expert. I don't know as much about Kafka as I should. So I get to rely on people who care deeply about Kafka and its bindings to figure out these are the important things that we should be thinking about when we're configuring Kafka. And AMQP and that's, the list goes on and on. And that binding can, configure, because we're at different levels, we can configure sort of queue level things, it can configure server level. It's pretty fantastic just to have that access to that knowledge. And the spec serves the purpose pretty well. I mean, in its original and current conception, the spec represents a file per application. And so, yeah, this can be how you interact with the application, but it also can really lead you on the correct path for implementation, or at least give you a head start for it, and give you the associated infrastructure. And we have an info object that can give you a little bit more detail about the implementation, and also provides versioning information, which is pretty key as we sort of move into multi-environment situation. The versioning above and beyond what a GitHub branch would tell you, semantic version becomes really, really key. So we're looking at some really good baseline here for things that can drive your SDLC. Then I think the final component of it is the tooling. I mean, we talk all the time about the great nature of the community here, and I think that's evidence of it. Rather than having to create the wheel over and over again at every different company or every different initiative, we have tooling that creates things automatically. And I think a fantastic example of that is code generation. And to sort of break up me talking for forever, I'll show you a brief little demo of something that we did at Solace that leverages not only the open source code generation, but AsyncAPI produces or hosts actually a endpoint that will create a code package for you. So that in just a little bit. So what's the conception here? The conception is that, and this is a very, very generic SDLC and some very specific different logos here, but you can envision this could be, your own custom SDLC, and it could also be your own custom logos in terms of the tools you use. But using AsyncAPI each step along the way here to interact with the lifecycle, and rather than having a proprietary file format that you use to sort of understand where your application is and what resources it needs, using AsyncAPI to one file to rule them all, in the words of Lord of the Rings. Use AsyncAPI instead. So as I alluded to earlier, I'll take a brief interlude here and run a demo of IntelliJ code generation. It's powered by the open source community. It's under the covers calls the AsyncAPI API, which I didn't even know it existed, and then a colleague find it, and we're like, this is exactly what we need. It's unbelievable, and then we found it through Slack. So nice little example of community. I will say that the way that we find the Async API is through a Solace product called Event Portal. You'll notice that in the demo, but they very well could be just you pick up the Async API file off a hard drive. So just know that, but I think the result is pretty cool. Async API, as you might guess, lets you define async interfaces. You can think of it as an open API for the event-based world. It's a relatively new standard, but it's gaining in popularity. You can create async APIs in development tooling, or products like Asapio can auto-generate them. Regardless of where the async API comes from, the async API importer can suck them into Event Portal and make them findable and usable by other developers. So here's a simple example of an async API file. You can see it defines the application itself and also the events that come in and out of it. Now we'll head over to the importer. It's a CLI tool that makes installation pretty easy. So we'll go ahead and install it. I should say that's because it's a command line tool, we'll run it as a command line, but it can also be used by additional tools like GitHub Actions or custom scripts. So we'll go ahead and initiate the command line here. Okay, now we've got a report for our import here, and we'll move over into the event portal and see what we've gotten on the other side. We'll refresh. Event portal organizes applications by domain, and we've specified a new domain for this called Acme Retail Automation. We'll click into it. And the retail customer mobile application that we described using the Async API is there for us to use. Clicking in, we can actually see the various different events that it subscribes to. And if we dig further, we'll actually see the schema that's being used. Now let's update the Async API and see that we can actually import new versions of the Async API if we want to. Let's say that we really want to have the product ID included in the included in the async API description that helps us be able to route things based on the product. So we'll add in the product to the async API, save it, and then we'll run the importer again. So now that the importer has completed, we'll go back to Event Portal, go back to our domain, and take a look at the application that we had defined there. You can see now that we've got a new version that reflects our updated topic strings for our event, and we're ready to go. So coming back from that demo, certainly it's not all rainbows. I think it would be appropriate, because we're always a growing community, to talk about the challenges associated with this particular approach. So I think it's interesting that, talking with Fran and Lucas and the rest of the guys about the growth towards version 3 of the spec. As we start componentizing things and promoting reuse, which I'm a big fan of, we also run into the problem of shared resources, both at runtime now and at more design time. And so I think that our approach at Solace, at least, is that rather than interacting directly with a pure async API, that the role of the async API catalog will come more into play. In other words, rather than somehow trying to figure out how things interact using flat files, having something more generic that allows those objects to relate in a more dynamic kind of way is going to become more and more crucial. That's it. Solace is on that. Dave has a fantastic open source product called, I believe it's called Event Catalog. IBM, I know, is looking into sort of solutions like this as well. I think it's a really intriguing space to think about. And then that, in turn, also provides a really nice place to link back into that Event API lifecycle that we talked about to begin with. In other words, the async API catalog creates a little bit of a buffer mechanism between the raw async API that you don't necessarily want all exposed out to your API consumers, and also provides a level of governance there. And a very specific example of that is, we have the ability to link in server information in the async API. That's certainly something you would want to have abstracted away from if you're having external people interact with your application, but perhaps even internal people. And the reason you would want to do that is, as we all know, sort of the physical mapping of servers changes all the time. Again, going back to Fran's sort of conception of late binding, if we're late binding to a protocol, we certainly want to late bind to a particular server, physical server implementation. One of the challenges, as we sort of have been thinking through our own journey at Solace, is that rather than having a physical server definition, it would be awful nice to have a logical server definition. In other words, this application gets deployed to the red broker group. In contrast, this other application gets deployed to yellow. But in dev, red broker group is a single broker because we don't want to spend a lot of money. But in production, it's a highly available cluster that will not be taken down regardless of whatever happens. It's a highly resilient production broker, and being able to map that, not in the async API itself, you might have a little layer of abstraction, but something that you're using behind the scenes perhaps to deploy your architecture, something like Terraform, something like Ansible, where there's a mapping between these logical concepts, logical broker groups, for example, and actual physical inventory of like, okay, this is the actual broker that things land on. So with that said, just another brief demo about deploying out infrastructure. In this case, we have an Ansible plugin actually that takes an async API and deploys that physical infrastructure, doing a crosswalk. We sort of have hacked together our own little logical crosswalk, logical into physical and then deploy out, in this case, Solace infrastructure. Obviously, we're interacting with the Solace binding. You can easily expand that out into MQTT or other protocols as well. So take a brief pause here to run that demo, and we'll see you when we get back.
Your event-driven applications need to have things like queues, topics, and subscriptions to work. It would obviously be better if you generated those things automatically, and even better still if that auto generation used an open standard. That's what Ansible plugin for Event Portal does. It uses AsyncAPI bindings, which are an open standard, so no weird proprietary stuff, to generate objects for a particular application. So we'll start off by checking out an AsyncAPI file. You can see up here that we've got a number of different server definitions. But as we scroll down, you can also see that we have a queue binding, or rather a technology binding for Solace. There's technology bindings defined within AsyncAPI for Solace, for Kafka, any number of different brokers. So we'll use this to drive our creation process. So we'll use Postman to kick Jenkins off, which will in turn call Ansible, which is a pretty common pattern. But just know that Ansible has a REST interface called Ansible Tower, so it's just a REST call. The REST call includes a path to an AsyncAPI file, which again contains a binding to either Kafka or Solace. And it also tells it what environment to deploy in. So just to prove that there's no funny business going on here, we'll navigate over to the GUI. You can see that there's no queues right now, but we'll look back over at Jenkins and see we just are finishing up with Ansible Tower. And we'll move over into the GUI and see what we have here. Now we have the queue here. So I should say that underneath the cover, Ansible hosts playbooks, which they're sort of their programming language, which can create underlying infrastructures for a wide variety of brokers. It also hosts something called an inventory, which can map between a logical label like stores or warehouse to the actual brokers for an environment. So you can use the same AsyncAPI file across multiple different environments.
So in conclusion, first of all, thank you. It's an interesting topic for me to think about, and this is definitely a prompt to think more deeply about it. And thank you actually to the wider community. Certainly in our efforts, in my efforts, being able to leverage the great work of the open source community has been really, really helpful, and hopefully, in things like the code generation, we've been able to donate things back as well. And finally, this is a work in progress. It's an intriguing topic for me, like I said, but I'd really welcome feedback and better understanding how these things work in your particular environments. So thank you, and have a great day.